Hello everyone and welcome to the physics lectures. In this lecture I am going to talk about the dot product and the cross product. In a previous video I've already talked about the vectors, the addition and dot product. I only gave the introduction, but in this video I'm going to focus only on the dot product and cross product. Dot product gives you the resultant, which is a scalar. Now this can be easily seen if you have two vectors a and b given a1 a2 a3 and b1 b2 b3, where these are the components, and this is equivalent to saying that a vector is given by a1 x cap plus a2 y cap plus a3 z cap, and similarly the b vector. Now a vector dot b vector is simply given by this equation, but this formula is only useful when you know each component of the given vectors a and b. But if you do not know the components and instead you know the magnitude of the two vectors a and b, then the dot product is given by this formula, where the modes represent the magnitudes of the vectors a and b, and theta is the angle between the two vectors a and b. Now this was all mathematics. We need to understand the physical meaning of a dot product. Suppose you have a vector a and then you have a vector b which is at an angle theta with respect to a, then the dot product of b with a actually means the projection of b on a, that is the magnitude or the component of b that lies in the direction of a vector. So this is essentially resolving the vector b in the direction of vector a. Now you can relate this dot product to the resolution of a vector, because dot product is what allows you to resolve a vector in the coordinate axis, where you simply use the coordinate system of x and y, and you have a vector, suppose v vector, and then you just resolve it into the x component and the y component. So to resolve this vector v, you just take the projection of this vector v on the x-axis, which is nothing but the dot product of vector v with x cap, and this was the reason why you obtained v of x equal to the magnitude of v times cosine of theta, because here x is taken as unit vector because it's only giving the direction, while here you have a vector itself, and therefore you have a different formula for the dot product. So even in this formula, if a vector were only a unit vector, then this magnitude of a would be unity of 1, and then this formula and this formula would be more or less same. Now we are doing this dot product especially in lectures of physics because it's very important when it comes to Newtonian mechanics, because in class 11 you use the Newtonian mechanics, and even in the first year undergrad we use Newtonian mechanics, where we have to understand the directions of the forces which are acting on objects. So for example, if you have a block of mass m which is being pulled by a force F at an angle theta with respect to the x-axis, and suppose in that question it is asked what would be the work done in dragging this block in x direction by a distance r. So to be able to do this, one needs to know the formula for work, which is F vector dot r vector, and as I said previously, that the dot product gives a scalar, so work is essentially a scalar. So this becomes something like this: product of magnitude of f and r with cosine of the angle between the two. And this has a number of other applications. So this was just a basic example to give you an idea where the dot product is very helpful, and it is important for you to understand how to take a dot product. And also it can be used to find out the angle between the two vectors, because if you have this formula, then you can just change it a little and say that cosine of the angle theta, which is between the two vectors a and b, is simply given by the dot product of a and b divided by the magnitudes of a and b. Now I'm going to talk about the cross product. Now one thing to notice is that the resultant of a cross product is a vector. So if you have two vectors a and b given by these equations, then the cross product is given by the determinant, which is given by this. Now you may be tempted to find out how we came up with this formula, but that is not important when it comes to just problem solving. You can look into many books where you can find why a cross b is given by this formula, and I recommend you to actually remember this form, because once you know how to find out the determinant, and then there is a mathematical way of finding this cross product. So the result is given by this formula. Now it's actually difficult to remember this formula, so I prefer to go with this one, because once you know how to solve it, you can just plug in the values of the components a1 a2 a3 and b1 b2 b3 and end up with this correct equation. Because in an attempt to remember this long equation, you might actually flip one or two values and end up with the wrong answer. Now that previous formula was applicable if we knew the individual components of the two vectors a and b. Suppose we do not know those, and we only know the whole magnitude of the vector and the directions of the vector, as in, so here mod of a gives the magnitude of a and e1 cap gives the direction of a, and similarly for the b vector. So in this case, the cross product is simply given by this formula, where theta is again the angle between the two vectors a and b. Now where do we find this cross product in physics? Actually, it is very often seen in rotation, where you have a vector called torque vector. So torque vector is given by force cross r vector. So as an example, if you have a force acting in this direction and the position vector is given by this vector, and this angle theta is the angle between f and r, then the cross product would be given by a vector which will not be in the plane of this video. It will be in the plane of your computer screen. So it's not easy to find the direction. I will talk about the directions of the cross products, but for now you can say, at least mathematically, it is possible to write the cross product still. So this would be given by the magnitude of the force times the magnitude of the position vector times the sine of the angle between the two. So now if you want to know the direction of the torque, if you know the direction of f and r, then you need to use the right hand curl rule. Now in this video I cannot demonstrate the right hand curl rule, but you can look in any book and you will find that rule for finding out the direction in a cross product, and it is very important actually to find that out. and it is always given uh, by a strategy in which you open your palm in the direction of the first vector and then close it towards the second vector, and then the thumb gives you the direction of the torque or the third vector. Now you can try this out on your own, listen to it again, and maybe read some book and you will get the idea.